Hey, welcome everybody. Thanks for showing up to our Unstructured Data Meetup. We do these once a month to get people together for discussions and collaborative learning about generative AI and unstructured data. This event is sponsored by Zilliz, the maintainers of Milvus, open source vector database. I think there's a slide here about GitHub of the Milvus project. How many people here know about Milvus? Okay, and great. And of the people who know about it, how many might be interested in giving a demo? If you are, let me know. Just come up to me afterwards and I can schedule you in. Okay, so anybody, how many people are looking for work? Okay, how many people have a job that you would like to announce? We can have time at the end. So yeah, if you have a job, we'll give you some time at the end to announce that. All right, so a little bit about Milvus. It's an open source vector database. It's designed to store, index, and search vectors, millions of vectors to use with generative AI and unstructured data. It's hardware optimized for CPU and GPU, many advanced indexing algorithms, over 26,000 GitHub stars, over 8 million pip installs, over 50 projects with over 1 billion vectors in production, 113 million Series B, more than 5,000 enterprise adopters, currently 5 SDKs, I believe, Python, Java, Node, Ruby, and Go. The enterprise-ready Zilliz Cloud is designed for higher speed, scale, performance, and it's ideal for searching billions of vectors, or yeah, actually trillion scale vectors is what we say. It has extra proprietary features, including RBAC, faster proprietary indexes, multiple availability zones, 99.9949s of availability, available as a managed or serverless, which we'll hear about tonight in just a minute from James, and runs on AWS, GCP, and Azure. All right, so with that, we're going to get started with, we have 3 talks tonight. So our first speaker is James. He's the VP of Zilliz, VP of Engineering at Zilliz. He has extensive experience as a database engineer at Oracle, Hedvig, and Alibaba Cloud. He developed HBase at Alibaba Cloud, their open source database. He's a member of the technical advisory committee of Linux Foundation, AI and Data. He has a master's in computer engineering from Cornell, and he's going to speak tonight about leveraging Zilliz Serverless, up to 50x savings for your vector storage cost. So welcome, James.
Sorry, HDMI cable is on the ground to your left.
Oh. Yeah, great. Yeah. Right. It's not. Yeah, okay, cool. Yeah, thanks everyone for joining us. So I'm James, glad to talk about the Zilliz Serverless tonight. So before we start, right, so what are the top concerns we Gen AI developers trying to use vector DBs? We actually built this interesting survey among all the Milvus community this year. So yeah, actually a lot of interesting part. Definitely one big thing is that how good I can get the search result, I mean search quality. So it's actually #1 reason when users want to build reg applications. Yeah, but there are still like a lot of different other perspective, like cost efficiency, like easy of use, like performance, stability. For large enterprise users, they care about high availability, they care about securities. So unluckily, we don't have enough time, so I'm not going to cover all those things, but I thought today is a good opportunity to talk about cost efficiencies and easy of use, like how you can build your reg applications from scratch, and also how you can save money on vector storage. Right, so you actually have very good applications. You have one ideas you want to put into production. You already have this pipeline, it works perfect. But what happens when you want to like put into production, right? Definitely, if your application becomes really popular, then cost per user becomes a really headache, right? We actually talked to a very large Gen AI applications. The key problem is like how many times, like how much they spend on generations, as well as like vectors stored, right? So I think second thing is how you're going to monitor your apps, right? Both on the search qualities, on generation results, like how you're going to evaluate all the results, right? Third thing is going to how you do multi-tenancy. That's become very critical. If it's two consumer applications, you're going to have million level tenancies, right? How you're going to handle this in one database? If it's for like two business, you're still going to have like 100 or even like 1,000 tenancies. That becomes a real challenge to put into production. That's not like building something for fun. You have like 10 users, you have like 1 million data at most. That is very, very different, right? How are you going to handle burst traffics, right? If you get luck, right? When the EU traffic grows like 10 times, how are you going to handle that? Your models, your vector DBs, those are become challenges. And last is availability. When you have very large traffics, how you still maintain everything work? Yeah. Quick recap, right? So what happens for most of the developers from day one, right? You have actually two choices. One is to build from open source. We actually have this open source. Milvus is actually pretty good with Kubernetes. You can do self-hosted on your local data center. You can also deploy on the cloud, works perfect. But to save you some time, I think I would recommend to directly use those called dedicated cluster. So as I just showed, this is a very general architecture. So you have multiple tenants in one Kubernetes. Each of the tenants is actually isolated, so we have great security. We isolate a distributed storage computation, so you can scale very fast. We actually have this index building pool. We have backup service. We have everything to help you to maintain it work correctly and like efficiently. Right, and also like since we store every data into object storage, basically it's going to be S3 or GCS, so your data becomes very safe. It's not like store everything on the local disk. One day if your machine crash, right, you lost everything, right? So you have to store it in somewhere really safe. That is object storage, but you can still have another layer of caching, so your performance become great. Right, but there are also like a lot of disadvantages when users want to like put Zilliz cloud into their production. One is definitely you have to spend a lot of money on it. Even if you have one capacity unit that starts from like $100, that is not good enough for like startups with 1 or 2 person, right? Yeah, and it also like grows linearly. So you have like million level users. Each of the user maybe just they just have like 10K vectors, but still, if you add them all up, it's still going to be a huge cost, right? And second thing is that it lacks the ability to scale with the workloads. So one day, if you got a lot of traffic, you have to like scale it like manually. It's not going to be the scale dynamically. So it's also bringing a lot of headache to maintain every like infras. Right. Third thing is that when data becomes huge, your performance also drops. So that becomes a key challenge, not only for Milvus or Zilliz, it's also for all the vector DBs. So if you have like for each of the tenant, if you have like 10K data, that's pretty good. But you have like more than 10 million data, so definitely to start about this. Right. And also important thing is that the expenses, right? Especially if you're trying to build agent, like applications, you have to like store as long as it has to be, because those are contexts, right? So I know a lot of like developers, they just try to like purge the data because they just cannot afford to store all the money, all the data into their vector DBs. So can we just maintain all the data, but don't save like tons of money? That is what we're trying to solve. Yeah. So here we have this called serverless. So first of all, it's pay as you go, so you don't need to worry about the, it starts from $0, so you don't really need to pay for anything. You get a generous free tier. And even if you go, right, it's still going to be 50 times cheaper compared to the dedicated cluster. It is dynamic scale, it supports multi-tenancy. We have different ways to do multi-tenancy. One way is just to support million level multi-tenancy, but multi-tenants, but we kind of like group every data into the same collection, but using filterings and other like isolation inside the collections to help improve the performance. And we also have like the other way, like you can build multiple collections for multi-tenancy. And it runs in all the cloud, no matter it's AWS, no matter it's Google Cloud, no matter it's Azure, right? You have all the monitoring metrics, so you don't really need to like worry about how good the performance is and how stable it is. Yeah. So how do we do that, right? So we actually use 4 different technologies to help to boost the performance. Yeah. First thing for sure is going to be logical cluster and auto scaling. So it's actually a very complicated system. I don't want to like talk too much about how it is implemented, but the only thing you want to know is it's actually logical cluster on top of physical clusters. So the physical clusters has all kinds of different nodes. We have proxies, we have streaming nodes, store your fresh data. We have query nodes serving for historical segments. We also have a bunch of resource pool helping to build index, helping to run offline jobs. Let's see if you want to run a Spark job on top of all the vectors. We can do that. If you want to do a clustering job on top of all your vectors to help you to find some abnormal data, you can do that. We also have meta service to store all the meta information, so it can be scaled to like billion level. We have logs. We have blob storage, that is we're going to use S3 or kind of GCS. So you don't have right, you're actually using a logical cluster, but we can do dynamic scale, so you don't really need to worry about maintaining the traffic. Okay. Second thing very important is that we actually distribute streaming data and historical data. That becomes very important, especially if you are trying to build Reacts and agent applications. Data freshness becomes very important. You can definitely use fast, agent double, like you build your own vector search libraries, but the tricky part is how you maintain the fresh data, right? Users going to talk to the app, generate a lot of data, then you have to like insert into the vector DBs, and they have to be like visible as soon as possible, right? So we have this strategy that we put all the fresh data into streaming nodes. So we use mutable index. It keeps data fresh. It's still searchable. It's not like efficient enough. But after a while, we do flush. We put everything into blob storage. We build high efficient index on top of all the historical data. So make sure that search becomes even more efficient. It also like saves you a lot of money, right? So when a search happens, we do a merge. So search for both streaming data side and also the query data side and merge everything together. It's pretty much similar to the Lambda architecture. Yeah. Third thing very important to save your money is the tier storage. As you may know, for all the vector DBs, most of the vector DBs just put data into their RAM, right? But that's the reason why vector DBs are so expensive, is because RAM is just like 100 times much more expensive compared to your SSDs, and it's like 1,000 times compared to S3s, right? So what we want to do is we really want to put everything into S3 as much as possible. So then you can have like much other storage, right? You can have much other history, right? So, and you have to build something like a swap. It's very similar to a traditional database, but it's not as easy because VectorDB has its own traffic. It's going to be very challenged because VectorDB has a lot of random access. We do build special index on top of it. Yeah, And last thing is about multi-tenancy, right? For a lot of vector DBs, we just store data in one large collection and you do filtering on top of it. It's definitely, for sure, it's not efficient enough, right? So what we do here is that we have multi-layer of caching for sure. First thing is that for very hot tenants, if they are active, we just put it into local memory or local SSDs. But if it's if it's code users, it didn't active for like last 7 days, we just put into S3. Although for sure you got penalties for on latencies, right? When you pull all the data from S3, yeah, but it still works pretty well. And you can pre-worm on it. So make sure that let's say if you're building applications, you can just when user open the application, right, you can just pre-worm and load everything from S3 into main memory or into your local SSDs. Then your latency becomes pretty good, right? We also adapted a lot of different optimizations on the data. So we try to partition all the data based on partition case and based on the class strings. Yeah. Then when your search happens, you don't really need to search every segment. That helps you to scale, right? So you just focus on the most relevant segment inside all the storage. You do a filtering. Yeah, that's also helped the search performance on a large data set. All right. So after we're doing all of this, this is something we get right now. It's not perfect, right? So when you do code search, the latency is actually not good enough, but it's still going to be work for a lot of applications. It's around two seconds with 1 million data set and 7 seconds with 10 million data set. Yeah, if you consider the performance of large language models, it's still acceptable. But once it becomes worm, right, then the performance become really good. It's become 100 milliseconds. That's good enough for like almost all the GenAI applications. And once it become hot, which means it put into main memory, then it become 4 single-digit milliseconds, right? But with the penalty of latencies, what you can get, right? You can get 50 times immediate savings on non-performance critical applications, the storage, right? If you're using performance instance on those clouds, it takes you $900 per month for like 10 million data set. If you use capacity optimized, which means you put all the data on local disk, you need 200. But now with serverless, you just need $16. All right. So yeah, that's its timeline. Well, we're just going to release this product this May. So it's just another like 2 or 3 weeks. Yeah, we're going to make it GA this July. You also get a free query ads for the first 1 million data and a lot of queries. So if you just the developers trying to find something that help you to develop, or you just kick off your business and you want to use something really cheap and easy of use, I think this cloud serverless will become your choice. So we're just seeking for probably beta users. So if you have interest in using like serverless, help you to solve the headache to maintain everything and also like improve the cost efficiency, please let me know. Yeah, that's pretty much for my talk. Yeah, thanks everyone.
Any questions? Oh, okay. Okay, I see one over there.
Hi, thanks for the talk. One thing I'm always interested in is for our business, one important use case that we use embeddings for is clustering. And this is quite a hard challenge with many trade-offs. But right now, it's one we have to do ourselves. As far as I know, no vector database supports clustering, no commercial offering. Why is it so?
Yeah, that's actually a very good question. So the reason why most of the vector database don't support clustering is actually because once you have large amount of data, distributed clustering becomes a big headache, right? So we actually try to fix the problem even in the serverless cluster. what we do is we actually have a background task called clustering. So what we're trying to do is when you have a large data set, we try to repartition the data into small segments. Yeah, and that has to be distributed. That has to be worked on like billion level data, right? So since we have all those resource pools and running all these kinds of jobs, so currently it's not exposed to our users, but we do have a plan to like expose a lot of different offline processing like ability to all the users. One thing is definitely clustering. The other thing is finding abnormal data on top of all the vector embeddings you have. Yeah, and the third way to do that, if you open source user, is that we have Spark connector. So you can use, because Spark has the functionality to do clustering as well. So you can directly use the Spark connector to connect to Milvus, using Milvus as a source, and Spark can do the computation for you. Yeah.
All right, so James is going to be around afterwards. If you have more questions, you can find him after the event.
Sure, thanks.
Okay, so our next speaker, yeah, let's thank the speaker. Okay, so the next speaker is Tengyu Ma. He's a co-founder at Voyage AI. He's the assistant professor of computer science at Stanford University. His research interests include machine learning, algorithms, deep learning, deep reinforcement learning, pre-training foundation models, LLMs, robustness. His Stanford lab alumni include 4 out of the 6 work now as research scientists at OpenAI, which is pretty good track record. His title that he's going to speak about is Voyage AI, Cutting Edge Embeddings and Rerankers for Search and RAG. Welcome, Tengyu.
Hey everyone. Thanks for having me here. Yeah, I love the Zilliz folks. We have a lot of collaborations with Zilliz. So we are Voyage AI. I'm Tengyu Ma. This is a company that focuses on embedding models and rerankers. I guess probably you have heard of the RAG, and which is the predominant approach for enterprise AI these days. So this is the architecture. So you have some queries, you have some corpus, you want to retrieve from the corpus some documents so that you can assist the large language model to give the large language model some context. And what you do is you say, I'm going to embed using embedding vector, embedding model, the queries and the documents. So you turn the documents into vectors, you turn the query into a vector, and then you put this document embeddings into the vector store, for example, Zilliz, and you also use the vector as an index to search the nearest neighbors in the vector store, and then you give the retrieved documents to a large language model for synthesizing an answer. So, and what we do at Voyage is the embedding model, which turns the documents and query into vectors. So, and what we do is that we start with a general purpose embedding model, which we train from scratch, and with a lot of data. And then we also customize the embedding model for different domains. So we have a code embedding model and law embedding model already live, and we are building finance embedding model and multilingual embedding models. And this could be a longer list, depending on how much granularity you want to be in. So, and then once you have this domain specific one, you can also customize further to a particular company. For example, suppose you are JP Morgan, then you can start with the finance embedding model and then further customize. Or you can directly go from the general purpose one to customize, because sometimes some of our clients or customers are in very kind of like niche areas, so that you have to start with the general purpose one. And then in the long run, you can also build a search system with continued feedbacks with from human feedbacks. For example, the users give some up, some down, and you can use those to further customize the embedding models to optimize the search quality. And we offer our embedding models in many different ways. There's a Voyage hosted API endpoints, which has all the models we have. And also we have the model integrated into the Zilliz cloud pipeline, so you don't have to have a Voyage API key, you can use the Zilliz API key to query on the Voyage embeddings. And we also offer it on Amazon Marketplace, Jumpstart. We can do on-premises deployment on VPC, and we also are in the process of putting our models on Snowflake, Amazon, Databricks, and so forth. What we really care about, how do you choose embedding models? What do you care about? I think you care about the quality of the search results. As James mentioned, that's one of the top, maybe the top kind of concerns people have when they are doing retrieval and rank. So, we have, there's something wrong with my animation, sorry. So we have done a lot of, we care a lot about the evaluation. So we have right now about 50 evaluation data sets we built in-house because some of the public benchmarks are a little bit of overused. And we evaluate very carefully all of our models on different benchmarks. So this is the evaluation for our general purpose embedding model Voyage 2 and Voyage Large 2, and we compare against OpenAI on these 11 data sets, which covers a bunch of different domains. And also we evaluated Voyage Code 2 for code retrieval tasks. These are 9 code retrieval tasks where you retrieve relevant code snippets based on semantics, and you can see that Voyage Code 2 is uniformly better than other ones, across the board. And today we just announced another embedding model called Voyage Law 2, which is customized for legal retrieval tasks. And we are the #1 on MTB on the retrieval tab under the law retrieval benchmarks. There are 8 data sets for law retrieval, and we are #1. This is probably not very good to read, and I guess this is a better way to read the numbers here. So we are basically the best on 7 out of 8 of the data sets and lead by a large margin in average. And interestingly, so we also, because legal documents are generally very long, so we spend a lot of time to get more long legal documents and also just generate long documents in the training set. And we have some innovative methods to deal with the long context, and we can support 16K context these days. And we also evaluate on some of the non-legal, just generally long context data sets, and we found that actually Voyage is still doing the best on just even without the legal aspect, just only on long context, much better than OpenAI. And also because we try very hard to kind of add different domains into this training set, because we saw that law also has intersections with many other things. You have a tech law, you have finance law, so on and so forth. So we had a bunch of different data sets into the training set, and we found that actually it's uniformly better than all domains now. So it's not even clear whether we should market it as a Voyage Law 2. So we have tested on medical, legal. For medical, it's almost the same as OpenAI. For conversation, we are much better. For long context and code and tech, we are better. Right, and the next thing I'm going to talk about very quickly is the re-ranker. This is a slightly different figure from the first figure I showed, where I add another component called re-ranker. So this is another component you can do in the RAG stack. So what you do is you say you initially retrieve some documents from the vector store, and then you re-rank them with a so-called re-ranker, which is a cross encoder. So basically the re-ranker I'm not sure why I'm okay. The re-ranker is like this. So you first do some search with the vector-based search, for example, and then you so you get some initial coarse-grained search results, maybe let's say 100 documents, maybe 50 documents, and then you send this to the re-ranker, which look at all of these documents and the query again and see which one is the most relevant, and you label the highest relevant, the most relevant documents with higher scores, and then you can take maybe top 3 out of these 100 initially retrieved documents, and that's a better that will give you a better quality, a better relevancy of the retrieval. So this is again an AI model, which under the hood is kind of cross-encoder transformer, and then we trained this AI model, and we found that at least in many of the cases, it improves the performance by a lot. And we compare with some of the other rankers. So basically here, you need to start with some embedding model, and then you apply it or some kind of like initial search, right? Embedding models of BM25, and then you apply the ranker on top of that. So basically the blue one is you do nothing, and all the other curves are different kind of rankers. And the green one is ours, which is often the best. Okay, so we have some early pilot customers. Of course, Zilliz is our friends, and we have a lot of collaborations. I'll talk about our integration into Zilliz, and also we have a bunch of other. This is actually not a complete list because we get more and more customers, and my slides are a little bit out of date. I guess we have some early pilot customers and distribution channels like Launchen, LlamaIndex. Actually, Launchen is also our customer because they have a chatbot called chat.launchen, which is used to people can use to answer Launchen's documentation questions about Launchen's documentation. So if you ask any questions there, you can query our embedding models. And Kappa.ai is this company that builds the QA chatbot for different kind of like companies, and they actually OpenAI is one of their clients. So they actually are the QA bot provider for OpenAI documentation officially, and we provide our ranker to them. So basically, if you want to understand how to use OpenAI, then if you ask Kappa.ai, you're going to use our ranker for understanding OpenAI, which is actually our competitor. Anyway, so and we are the official embedding models recommended by Anthropic. Anthropic doesn't have embedding models, and they recommend us in their official documentation. We are also trusted by Zilliz, so we have integrated into Zilliz in this very convenient way where you can just search like Voyage 2, Voyage Large 2, and you get to use our embedding models in Zilliz with just some clicks. I guess that's all I have. Thanks.
Thank you. Questions?
Thanks for your talk. Could you give a real-world example of what makes, for example, your law model better than the general model? Is it because you're running RAG on specific law documentation? Is it because you've fine-tuned? Like, how exactly is it better?
Yeah, so I guess how exactly it's better, I think mostly we use the numerical data because that's because otherwise it's going to be sometimes cherry picking. But I understand the question. So I guess the context here is that for legal documents, the retrieval is challenging because it's there's pretty much three challenges. So number one is that you have the legal jargon. Sometimes the embedding models are just don't know what some of those terms mean, or maybe they confuse those terms with other kind of like more common sense other ways of using of those terms. Another thing is that the legal documents are very long, so you need a long context embedding model that can read the whole legal contract or kind of like some kind of legislation and cases and up to sufficient details. And the third thing is that there's actually some reasoning component in legal, especially in some of this challenging legal work where you have to do some kind of analytical or deduction based kind of like reasonings to understand some of this legislation. So actually that's why we found that actually tuning on some of the other domains which requires reasoning actually helps law as well. So, and what we do is that we just get a lot of legal data. We optimize, for. So basically, we have done like a lot of research before I started this company on the embedding models. We have like 7 years of research on this, and most of the team has done research in the past and published papers. For the general purpose, in general, like the way we get high quality model is that we optimize everything in this pipeline. So there is a part about the innovative loss functions. We use some variants of contrastive loss, which we innovated on. So, and we optimize we choose the right optimizers, we choose the right data set, we choose the right architecture, we scale up with more machines, so you can train with hundreds of GPUs very fast, and all of this contributes to efficient training and and higher quality. And for particularly for law, I think mostly the we just try to get the right high quality data for law and get the right kind of like there's something called positive pairs, which is what you need to do when you train this kind of embedding models. You have to design the positive pairs that are basically pairs of related kind of documents or related queries and documents. And that's kind of, we have some innovations on that. How do we design positive pairs on legal data? And that's how we train better embedding models.
Yeah. Do you guys have room for another pilot project?
Yeah, of course.
Yeah, perfect. So how would this work with contracts for, so SaaS contracts compared to P&Ls? Would this work also for P&L? P&L, profit and loss, like Excel sheets with like transaction data, and work that against existing contracts.
Yeah. I think it should work pretty well, right? Because actually we are working both pretty well on finance and legal. So I guess what you are saying seems to be some intersection of finance and legal. Of course, if you your domain is very specific, if you really care about the highest performance,
it's probably just software.
Oh, okay. Yeah, but if you care about the best performance, we can fine tune on those kind of domains as well.
Another quick question. Do you have plans to extend this to multimodal?
Yeah.
And
so,
when? And when?
When is a little bit harder question. So we definitely have the plan. The only thing is that we have seen a lot of demands even for just text, and so we build a team with this in mind, definitely. And if you look at if I look back my deck 6 months ago, 8 months ago, I think definitely we have multimodal as one of the goals for the first 12 months. But I'm not entirely sure whether we're going to deliver it in 6 months. We will try. Yeah. The text can already do a lot of things, right? So even you have videos, probably if you just want something off the shelf and make it really work, you can just take the transcript. You do something like simple, it's called, you turn it into audio and then turn it into text, and that would already work pretty well.
You mentioned medical over there. Does that include images and videos that are like used by doctors, especially like learning students?
No, these are only text-based. So everything here in the results are text.
Just curious if you could like hypothesize how you guys were able to get ahead of Bloomberg or Nexus, like since they have already been in this industry.
Bloomberg?
So your classic legal searches are Bloomberg or LexisNexis, right? So how are you able to kind of get further along in this space than they have?
I think I'm not necessarily very familiar with those, but I think those are based on some of the classical search technologies, like the keyword-based search and the lexical search. I think these days it's pretty clear that a semantic-based, vector-based search is way, way better than those keyword-based search. Maybe in some weird cases, because the keyword-based search are optimized with a lot of like hacks, you cannot completely replace them. But I think it's pretty much the predictable future that, at least in my opinion, first of all, right now, definitely within whatever situation, if you have a traditional search and you add like a vector-based search into it, and you have a ranker on top of them, you're gonna get improved results. That's almost like a consensus. And I do think that in the long run, the keyword-based search will just be replaced by embedding models. Actually, one thing we found is that so we actually try to make the embedding models actually capture some of the keyword search. So in the training data, we actually specifically construct some of the training data where you only have keyword queries, like a few keywords in a query. And that already kind of help a lot to kind of like replace or partially replace the keyword search.
Maybe one more question. So first question was already answered, but can you elaborate a little bit more about the re-rankers? So first of all, did the output dimensions and the parameter size and everything change between version 2 and version 1? And what about the data that you trained on? Is this like, did you move it up in terms of like quality, textbook quality or something like that? Or is it mostly on the reasoning sort of within the component in between that is like re-ranking stuff?
So I guess it sounds like there are a few questions. So the first question is about the dimensionality between version. Now this is about embedding model, right? So for re-rankers, there's no dimensionality. You just re-rank the documents. So for the embedding model, I think our I think we have 1500 and 1000 to version 1024 or 1536. I think the latest version of Voyage Law 2 actually we make it 1024 because we found that 1024 actually works pretty well. Like we optimized a little bit to make it work as well as 1536. So that's why we actually reduce the dimensionality of the embedding models, even though the quality becomes better. And the re-ranker, sorry, what's the question about re-ranker?
If the re-ranker, do you think the re-ranker is the sole like this is the reasoning basically that improved the quality because you get quite some numbers in between. It's much higher. Is it the reasoning sort of that comes in through the ranking?
I see. So why re-ranker? The question, I guess, let me rephrase. Why the re-ranker can still can be useful on top of the first initial results? Why it can work better? So the reason is that the re-ranker sees both the query and the document together. So basically, you concatenate the query and document, and you send them to a transformer, which has the cross attention, so that you can look at both the query and the document together. But however, for embedding models, it's sort of like a two-tower thing. You first encode the query and you encode the document, and then you at the very end you do a cosine similarity or inner product. So the two-tower thing is limited in a sense that you don't see the enough kind of like nuances between the correlations between the query and the document, and that's why the performance sometimes is limited, and that's why you can expect if you have the cross encoder, then you can get the re-ranker, you can get much better performance. But the trade-off is that the embedding models, because they have the two-tower structure, you can pre-compute the embeddings for the whole corpus and then save them in the vector store. So that's a pre-computation, and that only needs to be done once. But for the re-rankers, you have to do it on the fly. So in terms of cost, the re-rankers is more expensive. That's why you only apply the re-ranker on a smaller subset of documents, right? So you only retrieve 100 and you apply re-rankers on 100 documents. You don't apply the re-ranker on all your 1 billion vectors there.
Thank you.
What is the meaning of the value that's output from the re-ranker? Is it some kind of arbitrary similarity score, or is it the probability that the document contains the information requested in the query?
Yeah, so it's a score for the relevancy, you return a score for every document, and this score is supposed to mean the relevance score between the document and query. There's only a single query and a lot of documents. So, and the score I'm blanking on whether we normalize it. I think we normalize it to 0 and 1. So in some sense, it's a probability, but I'm not entirely sure whether we did it eventually, because at the end of the day, the score itself doesn't matter. It's really about the ranking of the scores.
Thank you very much for the information which you shared with us. Our company is Ride-hailing. We're working around the world, and we're having jar reports in each region. And the question is, you have already basics reports which we can use from your model based on our data. And the second question is...
sorry, sorry, I didn't hear.
Yeah, sorry. You mentioned that you already working with jar reports and etc., right? So your model already know the data which required in such reports, or how? It's the first question. And the second question, you have computer vision which takes data from the documents and put it in the report, right?
Mm-hmm.
Yes?
This is not, there's no vision yet. So this is only for text so far.
Only for text.
Yeah, even though we are thinking to build a multi-model embedding models, we haven't got time to do it. We have people on the team who knows that very well. But right now its focus is vision. And for the legal, I think you are right. So basically the reason why the models know the legal jargon, know the reasoning in the legal context is because we are trained on a lot of public legal data. And that transfers to different settings as well.
And the last question, have you got data checks like for data consistency and etc.? Because we have different sources, even if we're talking about tax, and maybe there would be different data.
So the consistency between different sources.
Yeah.
Yeah. So so here, because we are not generating anything, it's now like we are really only the whole point of this is to test whether the document and the query is relevant or not. Even the embedding models, that's the final goal, where you want to know whether you are retrieving the relevant documents, whether the documents is actually the speaking about the truth or not. You know, that's not a concern for us. We are only thinking about the relevancy.
Thank you very much.
Yeah, so really cool work that you've done. My question is regarding the re-rankers. So the like basically you said that hey like the embedding quality it changes when you like it gets better when you customize it to like to a certain class of data. And I'm wondering if you did the same for the like for the re-ranker. Basically, if the like if the performance like differs when you customize it.
Yeah, so I think the we haven't got time to customize re-ranker. So for us, only there's a general purpose re-ranker. We have tested on different domains and we make sure it works pretty well on every domain. So I think that's what's happening here. So here, this is the test for the re-ranker, and we have different domains like conversation, code, law, so on and so forth. Actually, one of the, because this is our on top of the, I think it's not always helping a lot in all domains. I think in one domain, it doesn't help as much. I forgot which one it is, maybe finance. Wait, finance, no, not finance. Okay, anyway, but just we have tested on different domains, but at least it helps in every domain. It's just a different degree. You know, it also depends a little bit on whether your initial search method, the embedding model or the BM25, how well that works on each domain, right? So if the initial search is very bad, then the re-ranker give a bigger lift. If the initial search is already very good, then the lift is going to be smaller.
Thank you.
And we do plan to customize it for different domains as well, which we believe will be much better. So, for example, at some point, we're gonna have a legal re-ranker as well.
Thanks.
All right, let's thank our speaker. Thank you. And then I should mention that the integration with Zilliz pipelines is our RAG in a box product. And in the RAG in a box, you can do a drop down and choose several Voyage AI embeddings. Okay, so our next speaker, okay. Our next speaker is Laurie Voss. He's the VP of Developer Relations at LlamaIndex. He's been a web developer for 27 years. He co-founded NPM, which was acquired by GitHub. Here we are in 2020. Laurie cares passionately about making technology accessible to everyone by demystifying complex technology topics. So the title, he's going to speak to us about advanced retrieval-augmented generation apps with LlamaIndex. Welcome.
All right, let's see if we can get this fancy thing to work. Oh, it's going to complain, isn't it? Haha, it worked. All right. Hello, everyone. My name is Laurie. I feel like we've done these talks possibly in the wrong order because I feel like the first two talks were about very advanced aspects of how retrieval augmented generation works. And mine is going to be much more of an introduction. If, on the other hand, if you've been at sea for the last 30 minutes and you're like, oh my goodness, what is all of this stuff I don't understand? Hopefully I can help demystify just a little bit. what are we going to be talking about today? We're going to be talking about retrieval-augmented generation. What is it? Why do we do it? What are the challenges? How do we do it? And then we're going to go a little bit into what LlamaIndex does, how it helps you do this stuff. And then we're going to be diving into some techniques about how you can improve past basic RAG and get your apps into production. So let's start with retrieval-augmented generation, or RAG. Fundamentally, what is it? It is a response to a limitation of LLMs. LLMs have limited context windows. So you want to ask questions about your data, and your data is the most interesting data that you can think of. It is not the data that the LLM was trained on. LLMs are trained on mountains of public data, and your data is behind your firewall in an API on your Google Drive, wherever it is. So you want to give the LLM access to all of your data, but you can't give it access to all of your data all of the time, all at the same time. Even the largest context window in the world right now is 1 million tokens. And you probably have tens of millions or hundreds of millions of tokens worth of data in your organization. If you give ChatGPT all of your data, it will barf. There's just no way around it. You have to be selective. You have to give it the most relevant data, and figuring out what is the relevant data is the key to RAG. That is the retrieval part of retrieval-augmented generation. What do we get out of doing RAG other than getting around this basic limitation of we have more data than a retrieval-augmented generation than an LLM can possibly handle? The first is accuracy. If you give an LLM all of your data all at the same time, it's not necessarily going to focus on the right data. It is going to give an answer that ranges all over the place. What you want is the most accurate answer, and you also want a complete answer. So being selective about what data you give the LLM to say, answer the question about this and all of this data is an excellent way of getting an accurate answer. Closely related to that is faithfulness. One of the most frustrating things about LLMs is when they try to be too helpful and they hallucinate information that you didn't give them. Research into LLMs has shown that simply by giving an LLM exactly the data and saying, answer the question based on the data that I have just given you and no other data, don't think of other things, you reduce hallucination significantly, which is very important. Another big challenge is recency. One of the ways that you can get an LLM to understand all of your data, for instance, is to fine-tune an LLM based on your data. However, your data changes all the time. It might change every day. It might change minute to minute. Fine-tuning an LLM is expensive and also time-consuming. So if your data is changing all the time, it's not going to be practical to fine-tune an LLM. You have to give it real-time data using RAG techniques. Whoops. And finally, there's provenance, by which I mean you need to be able to say where you got the answer from. Sometimes being able to cite your sources is just an academic exercise, like it's interesting to know, but sometimes that is the purpose of the application. Sometimes what a RAG application is trying to do is find where you got that answer, in which case it's not just a nice to have, it's the point of the search. So those are the 4 reasons, very quickly, why we do RAG. Let's talk about how we do RAG. The core of RAG is retrieval, like I said, but there's different ways that you can do retrieval. The most obvious one is keyword search. For the last 30, 40 years, we've been getting very, very good at keyword search, traditional search like Google, and there's no reason just to throw out all of that advancement just because we've moved into the world of LLMs. If what you're doing is finding data that is based on keywords, using ordinary keyword search is an excellent way of retrieving the information first before you give it to an LLM. There's also structured queries. We have in technology vast databases of structured data in SQL databases, and there's no reason to throw those away or just convert them into giant piles of unstructured text and give them to an LLM. LLMs are capable of writing structured queries. They can write SQL for you, and that allows you to tap into your existing structured data and the metadata that's contained in them to be able to achieve the retrieval augmented generation that you want. And then there's vector search, which is the thing that we've been talking about most of this evening. It's the one that you hear about most, partly because it's the new kid on the block, but also because it is uniquely powerful. This is one of the bit that I'm talking about, which probably should have come at the beginning if you don't know how vector search works. What vector search does is it converts your data into numbers, just piles of numbers, specifically big arrays called vectors. The total set of vectors that you could possibly convert all your data into is known as vector space. And when you convert your data into vectors, it is known as, therefore, embedding your data into vector space, which is why the resulting data is called embeddings, which I think is a really weird name that's like 4 degrees of indirection away from what you actually did. But what vector search allows you to do, which is completely unique, is it allows you to search by meaning, because that is what the vectors do. They encode the meaning of the text rather than just keyword matching. So you can search by concept. You can search by things that are conceptually similar to what you're asking. And this is unique because it means when you have a question, you can also embed the question as a vector, and it will end up in vector space mathematically nearby to the answer to that question, because questions and answers are conceptually related. So you're able to pull, using quite simple math, the answers to your question simply by throwing your query into the same vector space. So that is how RAG works. You embed all of your data, you retrieve the most relevant context, and then you send that context and your query to the LLM. The LLM then answers the question, it contextualizes it, it summarizes it, it doesn't just regurgitate your context. So that brings us to LlamaIndex. We are an open source framework that connects your data to LLMs. We're available in Python and TypeScript, and we also have commercial offerings that I'm going to mention in passing because I'm here mostly to talk about the open source. Connecting your data to LLMs is something that sounds very simple. It's easy to say, it's very tricky in practice. Here is a typical flow of a RAG application. You load your data from your sources and you ingest it and you prepare it to be processed. Then comes your indexing, which is where you embed your data using the embedding models that we've been talking about all day, preparing it for vector search. Once you've got your embeddings, you store your embeddings in a vector database like Milvus. And there's all sorts of choices to be made about how you do that. And then when you're ready to query that data, you do the retrieval. You retrieve the most relevant context. And this is where, if you're using a re-ranker like Voyage, that you do the re-ranking. You retrieve 100 pieces of context, and you get a re-ranker to say, and here are out of the 100 that we've retrieved, here are the most relevant 10. Once you've got your extremely relevant context, you can combine that context with a prompt, and everybody knows that prompting is its own whole thing. And you send it to the LLM, which gives you your result. That might require further processing, like turning it into JSON or something like that. So usually I would then go into a deep code example of how all of this stuff is done in LlamaIndex, but I've only got 10 minutes, so I'm just going to be talking about stuff at a high level. Before you get started, you have to select your LLM. LlamaIndex connects to any one of dozens of LLMs, and every day more via APIs like Ollama or hosted options like BentoML. This is the 5-line starter of LlamaIndex. This is an entire functioning RAG application in 5 lines of code. In the first line, we load a bunch of files that are on disk out of a folder called data. Then we create an index, which is embedding all of that data and storing it in memory. Then we create a query engine, which is doing the retrieval for us on the next line, and then we print the response. This is the value proposition of LlamaIndex, is that you can get from 0 to a completely working RAG application in 5 lines of code, and you only have to customize the bits that you really want to customize. Obviously, every single one of these lines of code can be exploded into 20 or 100 lines of additional code if you want to customize For instance, what if your data isn't in static files? What if it's in a Google Drive or Notion or Slack or a database of some kind, like I was talking about? We provide a registry of hundreds of pieces of software called LlamaHub, each of which allows you to connect to a different data source. So we have pre-built connectors that will connect to any one of these databases for you to extract your data from where it lives before you have to send it to your LLM. What if you have a bunch of really complex documents to parse, especially PDFs? LLMs are uniquely bad at understanding what's going on in a PDF. And to solve that problem, we created LlamaParse, which is one of our commercial offerings. LlamaParse is an industry-leading PDF parser. And what it does is simultaneously very complicated and very simple. It understands deeply nested tables, diagrams, graphics, handwritten notes, anything that you can throw at it. And what it does is it turns it into Markdown, because it turns out that LLMs are actually very good at understanding Markdown. They were trained on enormous volumes of Markdown. So if you convert PDFs into Markdown very, very efficiently, which is what we do, you can make it you can get significantly better results out of your RAG application. Having talked about parsing brings us to indexing. We support all sorts of embedding models, including Voyage. They're big friends of ours. All of these different embedding models have different characteristics. As the previous speaker was saying, you want to select an embedding model that is tuned to your domain. So now you have all of your embeddings and it's time to store them. We support dozens of vector stores, including our friends Milvus. There's a lot of differentiation in this space in terms of the features they provide that I don't have time to go into right now. So now I said we're going to talk about some advanced strategies. We're going to be talking about some advanced strategies very quickly and at a high level. The first one is something that we conveniently package up for you as called the sub-question query engine. The problem we're trying to solve with the sub-question query engine is basically complicated questions. If you have a complicated question that requires being answered by multiple different simpler questions or from multiple different data sources, the sub-question query engine can do that for you. What it does is it uses the LLM to break your question up into a set of smaller, simpler questions, and it routes those questions to other data sources and asks the simpler questions. It then takes all of the answers that it gets and uses the LLM again to combine those separate answers into a single combined answer to your question. The next problem that we want to tackle is precision. Basic RAG can struggle with making sure that the context is precisely related to the query. And one of the ways that you can handle that is a tactic that we call small to big retrieval. What you do with small to big retrieval is you take your data and you break it up into very, very small chunks on the order of like a sentence. Then when you do your retrieval system retrieves only one individual sentence that it knows is extremely related to your query because it's very short and can only contain the context to your query. That means it's extremely precise. However, it's probably not enough data to actually answer the question. To answer the question, it needs broader context around that chunk that it just found. So that's where the small to big part comes in. It retrieves this very accurate, this very precise chunk, and then it looks before and after that in the document and returns 5 sentences on either side and reuses that as the context that it passes to the LLM. To significantly improve simultaneously the precision and the amount of context that you get. Small to big precision is precision by post-processing nodes, but you can also get better precision by pre-processing your nodes. One way that you can get an LLM to work better is by using the metadata that you already have. There's no reason that you should ask your LLM to figure out a whole bunch of stuff about your documents that you already knew. For instance, if you are working with financial documents, those financial documents are related to a specific year. There's no reason that you should have to ask the LLM to infer what year the document is from if you already knew that. You can put all of your documents into your vector store pre-tagged with metadata that says this is the year that this document was from, and then you can get the LLM to do the filtering for you. You can say, here, are the keys that I've created, the metadata keys that I've created on all of my documents. I want you to filter these down first by the year that I asked the question about before you do any further processing. You can get the LLM to do that for you, which is extremely useful. You don't have, it doesn't just have to be the year, it can be any arbitrary metadata, for instance, like what user is this related to, what company is it about, that kind of stuff. As you can see from this list, nearly all of the vector databases that we support also support metadata filtering. The next example is hybrid search. We were talking about this earlier as well. Keyword search, like I said, it works really well in some cases when you are searching for specific keywords. Other times, vector search works better when you are searching for specific concepts. But the problem is you don't know which one of those things your user is going to do. Your user is just going to ask a question, and you're going to have to figure out whether or not the result would be better from keyword search or from vector search. And hybrid search basically does both at the same time. You run the same query through keyword search and vector search, and both of those results come back with confidence scores from the relevant engines. And hybrid search basically combines them and says, okay, here's the highest scored one across both of these methods. And I'm going to say that that's the most relevant thing, whether or not it came from keyword search or from vector search. The list of vector databases that supports hybrid search is a little bit smaller, but it is twice as long as it was because all of the vector databases are rapidly adding this feature. Another very common advanced retrieval use case that I mentioned earlier is wanting to query a SQL database. There's no end of really great data in SQL databases, so the use case here is really obvious. And LLMs are capable of writing SQL. So all LlamaIndex has to do is connect your LLM to a SQL database and run the queries that the LLM generates. The thing that we have discovered here is that while you can ask an LLM to write SQL queries, it works much better if you know something about the queries that you're going to run in advance. So you can give it the schema of the tables. That's a very simple thing to do. We have data structures that allow you to give all of the schemas of all of your tables to the LLM and allows it to, based on the descriptions of those tables, select within all of the indexes first and say, okay, out of all of the 100 tables in your schema, these look like the 3 most relevant tables. Give me those schemas, and I will answer questions about that. But you can go even further. You can give it examples. You can say, here is a query that looks kind of like the query that I'm expecting you to have to run in answer to this question. This is what it looks like. And that gives the LLM a much better chance of generating correct SQL, including complicated joins and things like that. And the final use case that I want to talk about today is also the most complicated because it isn't just a retrieval strategy. It's an example of an agent in LlamaIndex. An agent is a semi-autonomous piece of software that can make decisions in response to a goal. You give it a query and you say, this is the thing that I need you to do. And here are a set of tools that will help you answer that question. You simply describe these tools using natural language. You say, here is a query index that knows about documents about Uber from 2010. Here is a text-to-SQL interface that will query a database that is about cars. Here is a sub-question query engine, like that thing that we were building earlier, that knows answers to questions about, I don't know, supermarkets. I'm picking nouns at random at this point. The way that an agent works is that it uses these tools until it satisfies the goal. It can look at each tool in turn and say, what do I already know? What do I need to know of the tools available to me? Which is the one that's most likely to be able to answer this question? And then it uses that tool to answer the question. And it will loop until it has either retrieved all of the information it needs to answer the question or decided that it can't. Our favorite example of this in the wild is our demo application, secinsights.ai. This was initially intended as a demonstration of LlamaIndex, but it's now a fully open source application that you can download and fork and use for your own purposes. It answers questions about financial filings about various companies, and it uses a variety of sophisticated agentic strategies to answer those questions. But the coolest thing about agents is, as I mentioned, the tools don't have to be simple query engines. The tools can be any of the previous strategies that I was talking about. You can compose all of these tools and all of these strategies together into an agent and produce really quite complex and subtle pieces of software that are capable of answering very complicated questions indeed. So we've seen how to build some amazing things very, very briefly, which brings us to the final step, which is getting it into production. I hope that we have some listeners here to the Latent Space podcast. It's an excellent podcast. And the host of that podcast recently referred to 2024 as the year of LlamaIndex in production, which is a quote that I'm going to be using over and over until he gets sick of me. One great way to get your applications into production is to use Create Llama. Create Llama is a one-liner that is an application generator. We wrote it for you. It asks you a bunch of questions about the kind of application you're building, and it puts together an application for you. It puts together a front end in JavaScript and a back end in your choice of JavaScript or Python, and it gets you over a lot of the getting started humps on your way to building a full stack application that does RAG. So I recommend checking it out. I hope that this flying tour of LlamaIndex and the things that it can do and the AI space in general has been useful to you. I think the thing that I want everybody to take away from this is that while it feels like, it might feel like everybody dived into the AI space already and you're late to the party, that is absolutely not the case. 2024 is the year that everybody is going to be showing up and the party is just getting started, and I'm glad you're here. Thank you all for your time and attention.
Thank you. I think we have time for maybe 2 questions, and then you'll be around later in case you want to follow up. So 2 questions. I'm going to go because I can't reach. Can you come forward? I'll reach you first.
Thank you. I would like to know if you can share some experiences using knowledge graphs, because you talked about different retrieval strategies, and I know LlamaIndex has a section on the docs about knowledge graphs, and within our company we're always challenging how good they are and for which use cases, and I wonder if you can share some words about it.
That's an excellent question. Usually this talk is longer and I had to throw out a bunch of stuff, so one of the things that I threw out was knowledge graphs. One of the reasons that I threw out knowledge graphs is because people tend to reach for them instantly. People tend to reach for them before they need to. One of the things that LLMs are really good at is figuring out the relationships between entities. So we've found that simply giving your data as a block of text to the LLM and getting it to figure out the relationship between the entities is more productive than trying to use a knowledge graph to figure that out. Unless, it depends entirely on the quality of your knowledge graph. If you've got a really rich and complex knowledge graph that you've been building up for years, then we recommend using our knowledge graph index. It is a feature of LlamaIndex. But if you have just a pile of data and you're trying to infer relationships from it, which is what a lot of people are trying to do, it's better to let the LLM just do that from raw text than building a knowledge graph itself. But it's a great question.
So I think text to SQL is going to be one of the most commonly used design paradigms in this space. However, so far I haven't found a single product or LLM that is production ready, like reliability of 5n's or larger. I was just wondering if you have found something that is reliable, or is there still a ways to go to get something that's really production ready?
We have seen some projects that have done really, really great work in the text to SQL space. The problem with text to SQL is not getting it to work, it is getting it to work cheaply. If you're using GPT-4 or you're using Claude Opus, they are really very good at generating SQL at this point, especially if you use the tactics that I was talking about, where you give them examples, you give them lots of schema information, You give them pre-existing queries that you knew worked. One of the things that you can do is if you are building a data querying system, you probably already have a huge history of queries that you've run. You have an existing body of reports. You have an existing body of SQL that you've run. You can just give that SQL to the LLM as context and say, here is how we've run SQL previously. And that makes the LLM much, much more capable of writing error-free SQL.
Well, let's thank our speaker again. Thank you. Very informative. Okay, as promised, at the end, we're going to have a community demo. And also, if people have job openings, is there anyone you would like to take the microphone and announce what you have? Okay, I see one.
Hey everyone, I'm Aaron from Epic AI, and we're building emotive avatars, the UI for many of these like RAG-based systems, and we're hiring research scientists here in Silicon Valley and also in London. So we're like a hybrid team between two places. So come find me if you're interested in chatting.
Okay.
Hi, everybody. My name is Mike. I run a company called Tecton. We help people put AI and machine learning into production. We are hiring across many, many functions. So ML engineers, designers, even salespeople. So if there happens to be a really technical, like pre-sales engineer or something like that here, please come chat with me. Yeah, thank you.
Okay, anybody else going? Oh, one more.
Yeah, just very, very quickly. I'm Christoph, working for a company that is providing software as a service vector graphics in the browser called kittle.com, KITTL.com, and we're hiring machine learning engineers, front-end engineers, back-end, and data scientists in London and also soon in the US. So hit me up.
Great. Sounds good. All right. Anybody else? All right. Okay, so welcome Kasey, who is one of our customers, who is going to demo Upstage. And I'll just leave it to you, Kasey, to introduce your product.
Thank you. Hey, everyone. Kasey from Upstage. Today, I'm going to do a quick demo of our full stack LLM offerings. Just quickly of introducing Upstage, because I would imagine not all of us have heard about us. The company is actually, we're focused on enterprise AI solution. The company started in Korea, Seoul, Korea, but we expanded to the US shortly after we closed the Series B. The news came out yesterday, so it's a fresh news for us. But yeah, basically we started with a OCR technology. We call it document AI, where it has a superhuman accuracy level of parsing out PDF and the text images from the documents, and then use that data, like make that usable for the data analytics. And then when the ChatGPT came about, we introduced our own model, a foundation model called Solar. So Solar is actually, our pre-trained model, which we developed from scratch. And we're now serving the Korean market. But now, after we open sourced the model on Hugging Face last December, we saw a huge demand in the US market. So we're expanding here. We're focused on developing small scale customizable models. So we're not doing this large general purpose model. It's very small, but still powerful. So when it comes to once you start thinking about how do I scale the application of the LLM, this becomes a very good, attractive option, because you can be, the speed and the cost wise, it is more appealing. And because we're serving enterprise customer, we realize that there's a huge demand for serving the end-to-end solution instead of like just doing the point solution. So we're offering the full stack so then the enterprise customers can, deploy the whole end-to-end experience through us. Our customers are like large enterprises, like I mentioned, like Samsung, LG, Korea Telecom, which is like AT&T of Korea, and a few other, large CRM, ERP solutions are currently using our technology. The vision for us is basically we want to have end-to-end experience through us, whether that's a structured data, unstructured data. We have the layout analyzer, embedding model, solar foundation model, and some of the answer verifier, the a few other components that complete the experience. And today I'd like to demo two products, a layout analyzer and as well as the generative model, which is Solar LLM. Layout analyzer, why are we excited about this is obviously everything in the data world is garbage in, garbage out. And when we've been working very closely with enterprise customers, what we learned is that like good enough is not good enough. You have to be better than human like manual labor. Then that's the only time they will actually say, hey, I'll pay for the big money and then deploy your technology at a full scale. So we spent last 2 years since we started in 2020 to develop a very high quality layout analysis, which we developed from scratch. And the idea is basically any kind of document, whether that's a PDF, image, we detect the tables and figures within the documents and serialize the contents to HTML. And the performance level is again 95%. So if you look at the benchmark here, our accuracy is actually much better than most of the open source and available model. Speed is not as much of a concern because what we learned is that for enterprise customer, they care about the accuracy much more so than the speed because they typically process the documents at a batch basis. So to show you how this works, actually, if I exit out here, we can go directly to our console. The address is console.upstage.ai. You guys can come check it out as well. We have a playground where you can basically experience our products. And this is the layout analyzer that I mentioned. The idea is very simple. We have this like charts, for example, and if you just like use like simple CR, it's not gonna understand, like, for example, actually better example would be this. Like when there's a paper that has two columns of data and if you just use the OCR, sometimes it basically doesn't understand that there's two columns in the paper and it fails to parse out the information in the right chunks. It doesn't understand the layout, and our technology basically, accurately understand the dynamics within the data and parse out the information in a very usable way for the further analysis. So when it comes to thinking about deploying RAG, you need to have, and you have a lot of PDF data or images like these manuals. Using a layout analyzer basically improved your model accuracy just by having the better quality data. So these are all examples of how our layout analyzer is able to parse out information. And a more interesting one is probably how this can be paired with the generative model. So before I get to the demo of that, just to give you a little bit of idea of what kind of model that we offer is, again, we focus on the small model. Our model is typically, below 13B size, but still, if you look at the performance metrics, we're very, strong. The chart is a little bit, misleading because the score is ordered in a, opposite order. So this is one of the Wisdom Cup, very, prestigious academic conference where they had a competition to participate on the conversational multi.QA, which is essentially RAG, right? Question and answer, and having a right, answer. And the independent team of researchers participated in this competition. And the one who used our solar model basically won the competition and got awarded. And this is just one quick, showcase of our technology. And speed-wise, obviously, because our model is much smaller, the speed is much better than some of the OpenAI or other competitors. And just for the enterprise use cases, if you think about it, because we built the model from scratch, what that means to us is we're able to train the model with the custom data that they have. So we're specialized in developing custom model, and whether that's from pre-train, continuous pre-train, fine-tuning, alt-reg, we're basically able to do all of that for the customers. So go back to the demo. We have in our console, we have a chat documents, which is a showcase of, let's put one of the sample documents. For example, let's do this and see how we can pair this up with the generative model. The original document looks like this. This is NVIDIA's earnings report summary article, and then it has a lot of charts that like if you scroll down, it's got the financials and information like this. And using the layout analysis, it basically transfer this information into HTML format like this. And you can ask questions. So let's ask question of a very simple one. Okay, that was easy, but let's ask information about the financials. What's cool about this is that it actually points out where it parses out the information, so you can actually refer back to like the source information. And like some advanced question might be like quarter to quarter increase, let's say. Let's see if this experiments. So my question must have been not specific enough. How much?
You can use that little microphone on the podium.
I see. Thank you. Yeah, how much the revenue increase from previous quarter? All right. There we go. So the question has to be still refined, but basically it's able to parse out some of the information in the documents. Other example is actually like, if you look at the news article like this, it's got a multiple like different columns, which is like harder for the layout analysis to understand, like that you need to read this column first and then this way and then this way and then this way. The article is basically talks about, let's ask what this article is about. So a little bit of summary, but we can ask a very pointed question, which I think if you look at like here, like somewhere, it's got the number to the social service office. So what's the number for social service offices for assistance? Cool. Yeah, so basically like just a simple showcase of how this tool is able to query the information that we need. Very simple, but the intention for us to having this demo is for the users to understand what's possible. And if you actually, this is like a use cases that you are interested in developing your application. We have all the APIs that's available for you that you can utilize, like layout analysis, the chat that I showed. All of this is in like one shot in the console that you can use. yeah, so that's it. If you want to check out our console, this is the QR on the left side. And if you want to chat with me, I'm based here. Always happy to talk to, developers and the founders who are looking to use our products. So yeah, connect with me. Thank you.
Thank you. Maybe we have time for one question and then you guys can all go socialize. Yeah, let's see, I'll pick over here.
Yeah, so it's just a like a quick question about your groundedness checker. If you can just describe that briefly.
Oh yeah, the ground check. Yeah, I already unplugged it, but I can tell you more. But basically, the idea is that after our model LLM basically generate the answer, there's additional components. We call it like ground checker that basically check against the answer, like check against the source information and verify whether the answer is true or false. So the component brings an outcome that's like true or false. And if it's false, the model basically goes back and redo the search. And if it fails to do so, like you can have some logic there, but basically parse that, like say, hey, I don't know. Cause like the most, the hallucination is the biggest problem for the reg use cases. And one of the solutions that we found is inserting that additional component at the end to say like false is false. So we have, we can prevent the hallucination. Yeah. Yeah, I can share more. Yeah.
Okay, thank you to Kasey for volunteering for a community demo.
Thank you.
And yeah, so thank you all for coming. We always hope you learned something new from either a speaker or from someone that you spoke to or that you met someone new or changed your mind about something.